Hello everyone, myself Professor Dipali Vagurde, and today we will learn about permutations and combinations.
So in our daily life, a situation may arise where we can have to make certain arrangements or certain combinations. So in many situations, we arrange objects in a certain order. For example, arranging the books, forming the numbers, sitting arrangements. So such arrangements are called as permutations. And while in some situations we have to select objects in any order, such selection is called as combinations. So this is the example of permutations and this is the example of combination. So here for example we have three chairs and we have to arrange them in certain order. So we have if we have taken this type of so we take this sequence A, B, C. So we can arrange the chairs in A, B, C or A, C, B. If we choose this sequence B, A, C, then we can arrange them B, A, C or B, C, A. And if we choose this sequence C, B, A, then we can arrange the chairs as C, B, A or C, A, B. That means we can place the chair B after A or the chair C after A. And then C after B and then B after C. So we can choose any of the 6 arrangements. We can choose any of the 6 arrangements. So we have 6 choices to arrange the chairs. To arrange the chairs. And if we have to select any one of the combination, then we have either we can choose ABC, BAC or CBA. So we can arrange the chairs in this manner. So we have only 3 selections. We can select the combination in 3 ways only. So this is the basic difference between permutations and combination. That means permutations is arrangement. Permutation means arrangement and combination means selection. Permutations means arrangement and combination means selection. So in arrangement we can arrange the objects in any manner, in any order, and in combination we have to select any one of the combination. So the basic definition of permutations and combination. A permutation is the arrangement of R objects from n distinct objects in a specific order. That means if we have three chairs and we have to arrange them. We have to arrange them. 3 out of 3 chairs we are going to arrange. So here n is here R is also 3 and n is also 3. So we have to arrange the 3 chairs out of the 3 chairs. So a permutation is the arrangement of R objects from n distinct objects in a specific order. And if we have to arrange 2 chairs out of 3, then our R will be 2 and n is 3. N is total number of chairs and R is the number of chairs we have to arrange out of 3. So this is possible for small number of objects, but for large objects we have to use the specific formula. So this is the formula to arrange the objects. P is for permutation. So permutations of n objects taking R at a time. So the formula is n factorial upon n minus R factorial. We can write it as NPR is equal to n factorial upon n minus R factorial. So this is the permutation, and it is for not repeating the elements. So without repetition we can use this formula, and if we have to repeat the objects, then the formula is n raised to R, where n factorial is n into n minus 1 up to n minus 2 up to 1. This is the formula for n factorial. That is, if 3 factorial is equal to 3 into 2 into 1. And then a combination is the selection of R objects from n distinct objects without considering the order. Without considering the order. So this is the formula. It is also can be written as NCR is equal to n factorial upon R factorial into n minus R factorial. This is the formula for combination. Here we can use without repetition and with repetition in arrangement. Now let us take some example. Find the number of 3-digit numbers from 2, 6 and 5 with repetition and without repetition. So basically what we have to do here, we have to arrange the numbers to get 3-digit number. To get 3-digit number. So we have suppose we have 3 boxes and we have to arrange these numbers to get 3-digit numbers, number of possible 3-digit numbers with repetition and without repetition. So with repetition we have the formula as n raised to r, n raised to r. So here we have to take all the 3 elements. So our formula is 3 raised to 3 and this is equal to 27. So with repetition we can get 27 such 3-digit numbers from these 3 digits. Now if we don't want to repeat without repetition, that means if we don't want to repeat the elements, then we can put any of the numbers. Suppose we put 5 here, we put 6 here and we put 2 here. Or to select the unit place, this is the unit place, this is the 10th place and this is the 100th place. So we have to arrange the numbers in these boxes so that we can get 3-digit number. So for unit number, selection of unit number, we have 3 choices. Either we can put 2, 6 or 5. So we have 3 choices. Now out of 3, suppose we have put here 5, then we have only 2 digits to arrange in these 2 boxes. So 10th place can be selected as 2 ways. So if we put 2 here, we have 2 choices and now only a single digit is remaining. So this is 5 and this is 6. So we put 6 here, so we have only 1 choice. Okay. So the total number of choices are 1 into 2 into 3, that is equal to 6. That means we can form only 6 3-digit numbers out of these 3 digits without repetition. With repetition we have n raised to r, that is 3 raised to 3 equal to 27 numbers. But without repetition we have only 6 3-digit numbers. So this can be done using the formula also. P of 3 comma 3. P of 3 comma 3. So what is the formula? P of n comma r is equal to n factorial upon n minus r factorial. So here we have n is equal to 3, r is equal to 3. So 3 factorial upon 3 minus 3 factorial. And this is equal to 3 factorial is 3 into 2 into 1 upon 3 minus 3, that is 0 factorial, and 0 factorial is nothing but 1. So this is equal to 6 upon 1. So we have 6 choices. So we have 6 choices for without repeating any element. So we can, if we have to repeat the elements, we have 37 choices, or we can form 37 numbers, 3-digit numbers, and without repetition we can form only 6 numbers, 3-digit numbers. Now the next example, a class consists of 6 students. So in how many ways a committee of 5 can be formed? So here we have number of students. So we have number of students n is equal to 7, total number of students in the class, and we have to take only 5 out of 7. We have to take only 5 out of 7 and we have to form the committee of these 5 students. So we have to select only 5 students. Selection. Here we have to do selection. So for selection we can use the combinations. So what is combination here? This is N, C, R. So N is 7, C, 5. That is C of 7, 5. And the formula for this is 7 factorial upon 7 minus 5 factorial into 5 factorial. So we have to evaluate, execute it. So 7 into, we can write 7 factorial as 7 into 6 into 5 factorial upon 7 minus 5 factorial is 2 factorial into 5 factorial. So here we can cancel the 5 factorial, 5 factorial. Now we have 7 into 6 upon 2 factorial, that is 2 into 1. So after cancelling we get 21. So there are total 20 number of ways in which we can form a committee of 5 students out of the 7 students, and this can be done with the help of combination. So this is all about the permutations and combinations.